In this section, Lesson 2-2, Determining Unit Rates with Ratios of Fractions, we will build upon the skills learned in Lesson 2-1, but we're going to include more fraction work. I hope by now you have found a calculator that you are comfortable using and allows for you to easily enter fractions. Let's begin at the top. It says under the key concept that you can use what you know about equivalent ratios and operations with fractions to write a ratio of fractions as a unit rate. Let's focus on this key term, unit rate. Remember what I said about the word unit and how there are many words in the English language that begin with the prefix uni, like unicorn or unicycle. So the word unit is going to mean 1. So we want a rate that has a 1 in it. And typically the second number is the 1, but it doesn't have to be. The question under this section says that Tia skateboards 2/3 mile for every 1/6 of an hour. So it's kind of a very weird rate because of the fractions, and it's kind of hard to understand unless we convert it to the unit rate. Let's begin by setting up our complex fraction. Since we naturally say miles per hour, not hours per mile, we're going to start from top to bottom and write the number for miles, followed by, in the denominator position, the number for hours. Next, what we're going to do is convert the second number, which is the denominator, to a 1. Now, since we're working with a fraction and we want to turn that into a 1, we're going to divide by this exact fraction. 1/6 divided by 1/6 is 1, just like a 2 divided by a 2 is a 1, or a 0.3 divided by a 0.3 would be a 1. Whenever you divide a number by itself, you get 1. So why are they then showing that we need to multiply by 6/1? Well, that's because when you divide by a fraction, we really want to multiply by its reciprocal. This is the multiplicative inverse. And when you multiply across the top and the bottom, you're going to get 6/6. And that's how you get the 1, because 6 divided by 6 is 1. Now, remember the golden rule of math. If we multiply the bottom by 6, we also need to multiply the top by 6 as well. When we multiply across the top and the bottom, we're going to get 12/3. And 12 divided by 3 is 4. Certainly, you could check and do cross-simplifying. You could cross-simplify these to get 1 and 2, and 2 times 2 is 4. So, based on our fraction, and that our numerator represented miles, and the denominator represented hours, this would be 4 miles per every 1 hour. Notice that my answer here in sentence form is she skateboards 4 miles per hour. Now, I said we were going to build on the past lesson for lesson 2-1. And in 2-1, we were using these tables. Remember that the table is going to be separated into your different units of measure. So here we have miles and here we have hours. In the first column, we're going to place the values that were given. So this is the rate that we're given. And then we can show with these arrows what we're multiplying or dividing by to get to our unit rate. Making tables just helps, I think, conceptualize this concept. Okay, let's move on to the questions under the do you understand section. Number 1, under the essential question, we're going to answer why it is useful to write a ratio of fractions as a unit rate. Take a moment and write that information down. It is definitely difficult to understand the speed that you're going if we're working in fractions, like 2/3 of a mile every 1/6 of an hour. It's really hard to understand, like, is that fast? Is that slow? But when we convert it to the unit rate and we get a single hour and that we travel 4 miles in that hour, we get a better sense of the speed. Okay, so if you compare this to, like, you're traveling in a car and a car can go 45 miles an hour, this is pretty slow. So it's easier to understand the unit rate than it is to understand the rate in fractions. And that's what this is explaining. All right, number 2, using structure. Jacob mixes 1/3 cup of yellow paint for every 1/5 cup of blue paint to make green paint. How many cups of yellow paint are needed for 1 cup of blue paint? Complete the table below. Using this horizontally oriented table, we're going to see or fill in, right, what the units of measure are. So we're measuring in cups of yellow paint and cups of blue paint. And in the first column, filling in the values that were given, okay? Next, we want to figure out how much yellow paint we will need for every 1 cup of blue paint. Since I have both of the numbers written in the bottom row of this table, that's where my focus is going to be. So I have the 1/5 and I have the 1. So my arrow is going to go in this direction. And then I have to think, okay, am I using multiplication or division? Well, anytime you go to a 1, you're going to be dividing. In this case, we're going to be dividing by a fraction. We'll do 1/5 divided by 1/5. Remember, anything divided by itself is 1. But we don't really divide by fractions. We multiply by their reciprocals. So we're going to use the multiplicative inverse. So 1/5 times 5/1. If I were to multiply across the numerators, I would get 5. Multiply across the denominators, I get 5 as well. And 5 divided by 5 is 1. Since I am multiplying the bottom of this table by 5/1, I'm going to multiply the top by 5/1. Multiplying my numerators, I'm going to do 1 times 5 and get 5. Multiplying across the numerators, the 3 times 1 is 3. So I get 5/3 cup of yellow paint for every 1 cup of blue paint. And what I want to do here is change my improper fraction to a mixed number. That would be 1 2/3 cup of yellow paint. Number 3. How is making a table of equivalent ratios to find the unit rate similar to finding the unit rate by calculating with fractions? Use a specific example to explain your reasoning. Please write that down. We are simply explaining the directions or the steps that we need to take. When making a table of equivalent ratios, we're going to multiply both terms. You add an S there. We're going to multiply both terms by the same number so that the second term is 1. For example, if we're comparing 2/3 and 1/7, we would multiply both numbers by 7. Two-thirds times 7, or 7/1, is 14/3. And 1/7 times 7, or 7/1, is 7/7, which is 1. All right, let's move on to the 3 questions on the right-hand side of this page. Number 4, Claire boarded an airplane in Richmond, Virginia, and flew 414 miles directly to Charleston, South Carolina. The total flight time was 3/4 of an hour. How fast did Claire's airplane fly in miles per hour? Let's go ahead and set up our table. We'll set up this table vertically. And I would like you to go ahead and write in the units of measure that we need for this table. Our rate, the 414, is given in miles, and this 3/4 is given in hours. So our units of measure are miles and hours. The first row here, or the first row here, go ahead and write in those numbers. And we're going to convert to a unit rate. So take a moment, read the question again, the last sentence here, and decide where your 1 goes. It says, how fast did Claire's airplane fly in miles per hour? That's per 1 hour. So the 1 would go in the bottom right-hand side of this table. Next, go ahead and decide what we're going to multiply or divide the right-hand side of the table by to go from 3/4 to 1. Anything divided by itself is 1. So we're going to take 3/4 divided by 3/4. But we need to remember the multiplicative inverse. So we're actually multiplying by 4/3. So 3 times 4 is 12, and 4 times 3 is 12. 12 divided by 12 is 1. We're also going to multiply the left-hand side by that same 4/3. Now, without a calculator, you'll write 414 over 1, and we'll multiply that by 4/3. I always like to see if I can cross simplify, especially when I have some bigger numbers here. On this diagonal, we want to look for any common factors that I can divide out of both numbers. And since I can divide 3 by 3, I want to check to see if I can divide 414 by 3. And if you remember from last year, learning your divisibility rules, any number is divisible by 3 if you can add up your digits, and if the sum of those digits is divisible by 3, then the whole number is divisible by 3. 4 plus 1 plus 4 is 9. Can you divide 9 by 3? Yes. So you can divide 414 by 3. So we're going to cancel these out and write, we're going to factor out the 3 and then write the new number. So 3 divided by 3, that one's easy. You get 1. And 414 divided by 3 is 138. Next, we're going to multiply across. 138 times 4 is 553. 1 times 1 is 1. So she travels 553 miles in 1 hour on this plane. Okay, moving to question number 5. Brad buys 2 packages of mushrooms. Which mushrooms cost less per pound? Explain. So it's hard to decide which package of mushrooms are more expensive in the store. And the reason is that, you have different dollar amounts, but you're not ordering the same number of pounds. So this one is more expensive, but you're also getting more weight, okay? So you're getting more mushrooms. So what we want to do is convert these both to their unit rates, because if we can compare them, the cost per 1 pound, we can then see which is more expensive. Please fill in the units of measure at the top. In this problem, we're comparing the dollars to the number of pounds. So I'm going to use a dollar symbol at the top and then the abbreviation for pounds. And then same thing in the other table. LB is pounds. Okay, go ahead and fill in the rate that you're given in that top row of both tables. Going to fill in $11.25 for 2/3 pounds, and in this table $7.99 for the half pound. Okay, decide where you want the 1 to go and write it in the table. Since we're trying to find the cost per pound or per 1 pound, the 1 would go in the pound column at the bottom. Next, go ahead and write what you're going to either divide or multiply by to get to that 1. To go from 2/3 to 1, we would have to divide 2/3 by itself. So 2/3 divided by 2/3 is 1. But dividing by a fraction is the same as multiplying by its reciprocal. Since we multiply the right-hand side by 3.5, we're going to multiply the left-hand side by 3.5. Now notice I'm writing 3.5 only because this is a decimal, so you would multiply a decimal by another decimal. You would not multiply a decimal by a fraction. So these are the same number. Nope, this should be a 1. 3.5 is 3 divided by 2, which is 1.5. Okay, but I'm using decimals because that side is working with decimals. Now over off to the side, we're going to write $11.25. We're going to multiply that by 1.5. Go ahead and take a minute and do all that work off to the side, not just in your calculator. First, you're going to start by distributing out the 5. And in the first row, you get 5,625. Next, you're going to move on to that second row and then start with a 0 and then distribute out the 1. Add your 2 rows together. And put back the decimal. Now be careful with this because we're working with money. Money includes your whole dollars, your dime values, and your penny values. So this would be $16.87. But this number that I'm going to leave off is important because that helps you round your penny. Since it's a 5 or higher, we need to round the penny up. So this would be $16.88 for 1 pound of mushrooms. Go ahead and do this last chart on your own. Okay, to go from 1/2 to a 1, we're going to divide by 1/2, which is the same as multiplying by 2 over 1. On the left-hand side, since I have a decimal, I would not multiply by a fraction. So we'll just multiply by 2, which is the same thing. Off to the side, I have $7.99. Multiply that by 2, and we get 1,598, and we're going to put back the decimal. So the cost per pound is $15.98. Now that we have our unit rates and we're comparing the price for just 1 pound of mushrooms, it's easy to see that this package here is cheaper? All right, last one. Number 6. Jed is baking shortbread for a bake sale. The recipe calls for 1 1/4 cups of flour and 1/2 stick of butter. How many cups of flour will Jed need if he uses 3 sticks of butter? Let's go ahead and start with a table. Please fill in your units of measure at the top. Here we're comparing cups of flour and sticks of butter. Fill in the rate that you're provided in that first row. Now, since I know that with rates I'm multiplying or dividing, I'm going to go ahead and since I know that I'm going to be multiplying or dividing with these fractions, I'm going to go ahead and just convert this mixed number right to an improper fraction and plug the improper fraction into the table. So 1 1/4 cup of flour would be 5/4 cup of flour. And then the 1/2, well, we don't need to do anything with that number. Okay, now I need to go from 1 stick of butter, or I'm sorry, 1/2 stick of butter to 3 sticks of butter. So, you'd have to know that you're multiplying by 6, which might not be so obvious. So many students will want to convert to the unit rate first. And once we know how many cups of flour for 1 stick of butter, well, we would just multiply by 3 then, right, to get to 3 sticks of butter. Okay, what would we need to multiply 1/2 by to get 1? We would multiply by its reciprocal. 1/2 times 2/1 is 2/2, and 2 divided by 2 simplifies to 1. Next, we're going to multiply the left-hand side by 2/1 as well. 5 times 2 is 10. 1 times 4. Oops, hold on. Let me move that over a little bit. 1 times 4 is 4. We want to find out how many cups of flour if there were 3 sticks of butter. Well, that's easy. We just need to multiply by 3. Since this is a fraction, why don't we put that 3/1? 3 times 10, or you could do it the reverse, 10 times 3 is 30, and 4 times 1 is 4. And if we convert the improper fraction back to a mixed number, we get 7 1/4. Let me circle that too. So there would be 7 1/4 cups of flour for 3 sticks of butter. Okay, so the big lesson here is using unit rates to help you solve problems or to compare prices to find the better deal because it is easier to understand, an answer when you are in a unit rate.